Right. Now we are going to the next level. What do you see here? Hello?
Prism.
This is a prism. I think all of you know what is a prism.
Yes, sir.
I have already shown you what is a prism, and I have already explained to you what is a prism. Right? So you are seeing this like this, and the ray is entering here. Got it? Now there are some things that you should know about a prism. That's precisely what I explained. So you can see here, what is this? This is the incident. Hello?
Yes,
And
sir.
this dotted line is the normal, n dash, and this is the angle of incidence. And this point is E. See, the capital letters are the vertices, are the important points. A is this vertex, B and E. Okay? And angle A is angle of prism. It is called angle of prism. And in this case, it is 60 degrees. Okay? Well, it's an equilateral triangle in this case, but not always equilateral triangle. Alright, now you see here, this ray is incident and then it is getting refracted here, hello?
Yes, sir.
And then it is emerging. Now, if this prism was not there, this ray would have traveled straight, correct?
Yes, sir.
Now that because of the prism, the emergent ray is coming out like this. So, but for the prism, the ray would have traveled like this. Because of the prism, the ray is traveling like this. Now, if you extend this ray backwards, you see this blue colored thing? This is called as the angle of deviation. The ray was traveling like this, it deviated. Got it? So, prisms can be used for deviating the light. Clear?
Yes.
And then, well, you see, so therefore here the most important thing is what is the prism made up of? So, the refractive index of the prism becomes a very important physical quantity to be considered. And in the prism, you can have prisms of different angles. Angle of prism is extremely important. Okay, and now you will learn the theory in your higher classes, right? That the deviation, delta, what is this? This blue color angle you can see here, that is the angle of deviation. This angle of deviation is equal to mu minus 1. Mu is the refractive index. Minus 1 into A. A here stands for the angle of prism. So you can see that the deviation depends upon the refractive index and angle of prism. Here again, this is air and this is glass. Hello?
Yes, sir.
And mu stands for what? The refractive index of glass with respect to air. Now you see this formula, right? If the prism was not there, then what will be here? In this place, what will be here? Louder. Air. There will be air. And what is the refractive index of air? 1. So 1 minus 1 is 0. The deviation is 0. Correct?
Yes, sir.
If it is there, you can apply. Or if you had a prism whose refractive index is 1, then again you will not have any deviation. Right? Then where mu is the refractive index, A is the angle of incidence. You will have this derivation in your air class. Clear?
Yes,
So this is about the prism, and watch out. What is this ray? This is
Incident.
and most important thing here, you see this ray, the refracted ray inside. The refracted ray inside is making an angle here. You can see this angle here.
Yes, sir.
And in this case, according to this ray diagram, this angle is less than the critical angle. It is less than the critical angle. So this is the information that you can derive looking at this diagram. Clear?
Yes.
Any questions? Hello? Aryan is now telling. So I told something about 3 possibilities. One is this possibility, right? Now what are the other possibilities? That is what my friend is asking. Okay. Now let me help my friend. One is this possibility. Hello?
Yes,
So this becomes the angle of incidence for this reflection. Got it?
Yes, sir.
So this one, you concentrate on this. Okay? You concentrate only on this angle. This angle. Got it? Hello?
Yes, sir.
Now this angle at this surface. This angle now is less than critical angle. So therefore the ray is coming out of the surface. Got it?
Yes, sir.
Hello, the ray is coming out of the surface. Coming out of the surface. Now, if this angle was equal to critical angle, then this ray would have traveled along the surface.
But is it making 90 degrees?
Huh?
Is it making 90 degrees?
It is making 90 degrees with respect to this normal. This dotted line is the normal, man, M dash. M dash is the normal. So the refracted angle is measured with respect to the normal, no? Correct? Got it or not?
Yeah, but
No, if you are doubt, you tell, I will explain.
that was the dot.
See, now you will measure the refracted angle along with, about the normal. So this angle is 90 degrees. So it will skim along the surface. Got it? Now, that is if R is equal to C. Right. Now, if R is greater than C, C depends upon what? The refractive index of the prism material. Refractive index of the prism material. See, the prism is made of a glass of a refractive index 1.5. Then probably it will go like this. If I make a prism of say refractive index 1.55, then for the same angle of incidence, it will be equal to critical angle. And instead of making the prism with glass, if I make it with diamond, whose refractive index is 1.62, then for the same angle, it will become larger than the critical angle. Correct? And it will, for that case, this ray will be totally internally reflected. Correct? So this angle will be equal to this angle, according to the laws of reflection. Correct? Now again here at this point you examine. What will you examine? You examine whether this angle here is less than or equal to or greater than critical angle. Again, if this angle is critical angle, then this ray will skim along the surface. If this angle, right? If this angle is less than critical angle, then this ray will come out.
How will you compare it to the critical angle?
Because if I give you the refractive index, if I give you the refractive index of the material, see, if I give you the refractive index of the material, okay, this is going to be 1 by sin c. So if I give you this as 1.5, then this is 1 by sin c. Therefore, sin c is equal to 2 by 3. 1.5 is 3 by 2. Sin c is 2 by 2. Then c will be equal to sin inverse of 2 by 3. So if you see the sine table, so you will get the angle of C in degrees. You will get the angle of C in degrees. Hello, are you with me?
Yes, sir.
Now see, for example, here sine 2 by 3 means I will draw a right angle triangle with this as 2 and this as 3. Now please understand this very carefully. So if I draw a right angle triangle with this as 2 and this as 2, this angle will be what? Hello? 45 degrees. Hello?
Yes, sir.
This angle will be 45 degrees. And what will be this side? Root of 2 square plus 2 square. 2 square is 4. 4 plus 4 is 8. Root of 8 is what? Root of 8 is 2 root 2. Hello?
Yes, sir.
2 root 2. 2 root 2 is what? 1.4 into 2 will approximately give you 3. Got it?
Yes, sir.
Got it now?
Yes, sir.
So this will be 3 approximately. This side will be 3 units approximately. Right? So if you get sine inverse 2 by 3, then angle C will approximately be equal to 45 degrees. Got it?
Yes, sir.
So now if this angle is 45 degrees, hello?
Yes, sir.
Then if this angle is 45, then it will go along the surface like this. That's all. See, if I give you mu, then you can find C. I can also give you directly C. So numerical problem, they will give you the conditions. Then you have to use that condition and derive it. So here again there will be skimming or there can be total internal reflection. Again one more total internal reflection and it can have multiple reflections like this.
So one a conspiracy or one theory you can tell from my side.
Conspiracy.
Means a statement like
Conspiracy, what is it? What
means
do
our
you
own
mean? Huh?
theory type.
One theory. One concept or conspiracy?
Concept,
Concept or conspiracy. Okay.
So that you told that angle of prism is also dependent on it, all of business.
No. Angle of prism is made by you. See, I can make this prism of any angle. I can make prism. So A is something which I manufacture.
So that angle of prism is also important in all this process.
Yes, very much.
Because for example, if the angle of prism was instead of 60, it was 80, the incident ray would refract it.
Correct. That's correct. See now if this angle was different, then this angle also will be different.
It will be less.
It will be less. It will be less. It will be more. Correct. Now that's what. Having accepted this is A, we have to examine what is this. Whether it is greater than critical angle or less than critical angle, and accordingly take the decision. Clear? Any more questions?
So like if we get a value of a sine inverse and there is no definite angle for that value.
No, wait. Again repeat. You will get sin C, you will get some value.
Yes, sir.
You will get some value for sin C.
Yes.
Then
And for that sine inverse we will get another value.
another value, no. See, now here sin C is 2 by 3. So it is not always 2 by 3. It can be something else. Something else means again for any value you will be able to see the value of C.
So but if for that value if we don't have a definite angle.
No, it will always be definite angle. Don't worry. There will always be definite angle for whatever number you write here. There will always be. Hello, are you with me?
Yes, sir.
There will always be. Clear?
So because you took the nearest value.
Nearest value I just approximately calculate. If you see the log table, you will get the correct value. Okay, don't worry. Right? Anyways, I appreciate.
Angle in any dense medium, it cannot be equal to 90 degrees, so it should be always less than 90 degrees.
Critical angle.
It can never be 90 degrees.
What do you mean it can be 90 degrees? So if you have a layer like this and you are having the incident ray coming like this, right? So this angle is this one, isn't it? This angle is the angle of incidence. So you are telling that it should be like this. So then this angle of incidence is 90 degrees. Hello? Angle of incidence is 90 degrees. Now you see. See, your ray is see, it is traveling on the boundary. Now watch out. It should travel from a denser medium towards a rarer medium. See, if you say the ray is traveling along the surface like this, indeed it is making an angle of 90 degrees here. Hello? But this ray is not traveling from denser medium towards rarer medium. It is traveling along the surface. Then critical angle is not defined for this condition. Critical angle is defined for what condition? The ray should travel from denser medium towards rarer medium. See, that is the condition, and you examine that condition. Now your ray is violating that condition. Understand? See, concept of critical angle is defined only for that condition. You violate that condition, then you can't define. Remember, physics is like this. When you want to examine something, you see whether condition satisfied. Then you proceed further. Condition not satisfied, then you say I don't know what to do. Maybe there is some more science that you have to do. But at present, you don't know what to do. You should not try to guess some answer. Correct? So examine the condition. Condition is not set, then you can't apply that theory. If for that condition, there might be different theory. There can be different theory for that condition. We will apply the different condition. But not this condition. Correct? See, now you will learn many laws in physics. Each of the law is pertaining to law. What is law in physics? Law in physics is what? Relation. Relation between the physical quantities under condition. Right? Relation between the physical quantities under conditions is existing. So first examine the condition, then examine what is the relation. Don't Don't try to relate if conditions are not satisfied. Is it clear? Anything. See now, when you define refractive index, conditions apply. What is it? For a pair of given medium, for oblique incidence, for a given wavelength of light. You should see these conditions are there. Then you should go about doing it. See now, the Snell's law will be defeated if the angle of incidence is not oblique. Obviously. Got it? See, it simply gets defeated. Got it? And the angle of incidence must be greater than 0, less than 90. Hello?
Yes, sir.
So, the exact condition you want to measure is oblique incidence pin code, it should be less than 90 and greater than 0. For this condition only Snell's law is different. But this is less than or equal to and the for this also it is not applicable, for this also it is not. If it is equal to 90 also, Snell's law is not applicable. For it is 0 also, Snell's law is not applicable. It should be greater than 0, then only it is applicable. Is that clear?
Yes, sir.
See, science is so intense. And this intensity will be tested in your competitive exam. Otherwise, everybody knows Snell's law. But how intensely you know? And at that moment of the time, how intensely can you apply it? Are you trained? Is your mind trained for it? Now it is not trained, I know. But if you follow me, you will be trained. You will be tough. Your mind automatically will start thinking. In fact, I will make mistakes and you will correct me. Sir, no sir, that condition you left. You will start telling me, good. And I will be so happy at that day. Understood? The greatest thing for a teacher is the student should be able to learn more than the teacher. And he should tell the teacher this. Then I will be happy. Because I taught you so much. I gave you so much knowledge. Now you are giving me some knowledge. Thank you so much. That is Guru Dakshina for the teacher. Got it? Right. And I will accept it with humility. Okay. Any other question? Hello?
No, sir.
Shall I?
Yes, sir.